Hello there. Hello, Sven. Hello, Dave. Thanks for
Hey,
joining.
Hello. Thanks for having us.
thanks for having us. Great to be here.
Yeah, sure. Thanks for joining the second episode of Dev Conversations, where we host developers from the Swift community who contribute to the domains around tooling, developer experience, and server-side Swift. First of all, thanks, Dave, for all your work on iOS Dev Weekly since 2011. And thanks to you both for all the work around the Swift Package Index, which will be the center of our discussions today.
It's our pleasure. Yes, absolutely.
Yeah. All right. So for maybe those who don't know yet, Swift Package Index, if you could describe it shortly.
How could anyone not know Swift Package Index? No, I'm kidding. The Swift Package Index is a site that will help you find the best dependencies for your application. So any dependency that is compatible with the Swift Package the Swift Package Manager is welcome on Swift Package Index, and we index and discover a whole load of metadata about every package and display that to people who are browsing the site. And we also test compatibility for different versions of Swift and different platforms. So we have a build system, which I'm sure we'll talk about later, that is constantly doing that compatibility testing. And then finally, the big thing that we also do is host documentation for Swift packages. So any open source Swift package that has doc.c documentation within it, we will build and host versioned copies of that documentation for free for any package.
Right. And when you started it, from a product, both as a product and from a technical perspective, where do you start from? Maybe Sven, you want to talk about it?
So there was actually a predecessor project, the Swift PM library by Dave, that sort of kickstarted it all. And I was aware of the project that Dave had launched, I think in 2019, wasn't it, Dave?
It was.
Mm-hmm. Yeah. And in early 2020, I had built something that allowed you to launch a playground with a package as a dependency, so you can try a package in a playground. And I had the idea to connect that to Dave's project, Swift PM Library, and we started talking in March. I sent an email to Dave if he'd be interested, and then we had a call, I think almost the next day or a couple of days later. And it just so happened that Dave was discussing relaunching the project or rewriting the project in Vapor, because the original project was written in Ruby on Rails and had experience with Vapor. I had time at the time, and we sort of started talking, well, let's maybe join forces on this, or I offered to try my hand at porting Swift PM library and see where we end up, and that's where we ended up in a nutshell.
Yeah, and nowadays, already connecting to the next question, I took a look at the organization on GitHub that you have, and there are many repositories, many different pieces. There's a repo for the list of repositories itself. There's the server and a few other executables. There's so much to talk about, and I think that's where we could start.
Of course.
So my original question was if you had any, if you could consider other frameworks, but that's all you already answered, right? It was in Ruby on Rails, and I think it was a choice that you had to go with it, right?
Well, part of the thinking behind it was if it was truly to become a kind of a community hub for packages, and it was going to benefit from being open source, and if it was going to be open source, it had to really be written in Swift if it was for Swift developers. So Vapor was the obvious choice when we actually came to, because I think the Swift PM library was more of a prototype. I mean, it was work. It was a fully functional package search engine, but it was really more of a prototype. It was kind of early days, and so when we decided to kind of do it properly, Vapor was an obvious choice for the framework to do it in.
Right, and I assume it was before Async 08, right? When it had features and
it was actually right at the end of Vapor 3. Vapor 3 was the stable version at the time, and Vapor 4 was in kind of a late beta at the time. And I'd actually made a couple of commits to a Vapor 3 version, and then when Sven and I chatted, Sven said, "Oh, I think we should do it in Vapor 4." So we kind of started with the beta of Vapor 4. And I believe that Vapor 5 was just announced, I think last week. I read
right.
a blog post about it last week. So
Exactly.
we've had the entire lifespan of Vapor 4 is the Swift Package Index. Yeah.
Awesome. And
Start to finish.
in what ways do you think that it helped, and in what ways it brought limitations and difficulties?
So I'm a huge fan of Swift on the server. I've had a couple of projects previously of similar scale that were written in Python, in Python Flask and Python Django, the two popular frameworks. And it really, really helps writing a server-side Swift project when you have strong typing. The deployment story is so much smoother. I remember our services often struggling with memory in Python and the runtime exceptions that would kill you. Because you just, you would lack the type safety and lots of things happening at runtime that you have to tackle where they are the issues that you have to tackle at compile time in Swift. I do see there's some complexity around the type system that's undeniable. And I think in particular, the event loop future type in Vapor 4 before async await is something that is a bit of a beast. It is a bit of a learning curve to start working with that, and
all the flat map, all the operations around it.
You can't really. There's no way to work with that unless you understand flat map, and what that does, and how you nest these things. And concurrency in that context is tricky when you have an array of event loop futures. How do you transform those, and how to ensure that they run in parallel or they run sequentially, and when do they do one or the other? And more importantly, what's really tricky, or was at the time, was error handling in that context, because how do errors that happen in the event loop future context, how do they get propagated through the system? So that was tricky, but
that's a thing of the past now.
That's just a couple of weeks ago, we removed the last event loop future from the Swift package index code base. Now it's all async await, and it has nothing but helped the project in terms of code readability and just it's so much nicer to work with. I mean, you do get the hang of it after a while with event loop futures, but there's just this nesting you and the flat mapping you can't get around, right? Everything it sort of envelops, it goes through your whole code base. Once you have these things, it's like async await, right? Once you have something async await, it bubbles up through the whole chain. But async await is much nicer to bubble up than an event loop future, so we're in a better place there.
I'm not sure I ever got the hang of event loop futures. It was something I really genuinely struggled with, actually. Right from the very beginning, I found those very challenging, and if I still had to use them today, I think I would still find them quite challenging.
Yeah, I think it reminds me to some extent working with RX Swift, and like everything is a stream and so on. But from a deployment perspective, like nowadays I think we are in another stage where we have all the Linux distributions and so on. I remember deploying Vapor, having to install Swift in a Docker image, and before all the I assume you were also there, or like was it deploying ever a problem for you?
No, the deployment story has always been easier than Python projects with Flask or Django, because there you also need to install everything, and you need to make sure that your C dependencies, because on Python, when you use SQL Alchemy and stuff, you always need to compile some little C project, and you need a C compiler then to build the stuff, and or you maybe have binary distributions, but they are not always. It's like Python dependency management is no fun. So we were no worse off doing that in Swift, and the huge benefits we gain just in terms of memory. I mean, it's like, I think it's like 50 megabytes or something. It's just ridiculously small. You couldn't spawn a Python process, let alone do anything with it in the kind of memory footprint that we have in our current deployment, and just how rock solid it is. There is just, we screwed up a couple of times, but that wasn't the Swift language's problem. It's just, stuff that sometimes slips through, but just the sheer number of things that can't even slip through because you can't get it to compile in the first place if you screw it up. That's just just the refactorings we can do with confidence that are really hard in Python. You need to have a really solid test suite in order to refactor with confidence in Python.
It's a safety net, right?
Oh, absolutely.
That's exactly what I love about Swift on the servers, that you bring all that confidence from that the compiler gives you.
Yes.
And of course, we have an extensive test suite as well. That's the other half of the confidence. And I don't think you can neglect that side of it either. But yeah, certainly.
So that takes us also to the next question, which
I'm here
when
to
looking,
help.
We got those segues locked down, don't we?
I was looking into the repo of the server, and I saw there the dependency snapshot testing, and I said, wow, like it actually makes sense because it's an app that you can test. But how are the ins and outs of it? How do you spin? Do you spin a browser instance? How it works? Because I'm so used to testing on a simulator. How it goes for
yeah. So that's been through a few iterations actually over the 4 years that we've been running. In fact, almost it's more than that these days, isn't it? It's more than 4 years. So we started with snapshot tests that actually used the image-based snapshotting that we use Point Free's Swift snapshot testing library for our snapshot testing. And just to be clear, we do a couple of different types of snapshot tests. So we do snapshot tests that would be more like a unit test. So if we just need to grab some text and make sure that text doesn't change between test runs, then, for example, we snapshot test our SQL queries. So we output the SQL query and then have a snapshot test to make sure that's not different without us knowing about it. And also little bits of JSON and little fragments of text that we put all over the place. We're going to snapshot those and store those on disk. But then we also have full web page snapshots, which are snapshots taken of using a browser to render the HTML and CSS and images into the browser, and then an image snapshot of those. And we did use the snapshot testing library for that originally, but we did actually find some little bits of incompatibility there. Like it was during the transition from, for example, Intel to Apple Silicon, we found that sometimes there were like tiniest little pixel differences with the rendering of the browser that we weren't really in control of. And so
the tooling around it is pure Swift, or like does it have any other?
Pure Swift, yeah, absolutely, yeah. But these days we actually use a third-party tool. So we now take our snapshot testing for the HTML. So we output the HTML of a full page and store that in the repository. And then we run a tool called Percy, which is from a company called Browser Stack. And Percy is an online snapshot testing tool where it takes HTML and renders that HTML using a variety of browsers. So it tests with Chrome, it tests with Safari, it tests with Firefox, and gives you a web UI that says this pixel changed, or whatever, or this entire snapshot changed. And we find that very useful.
Convenient, yeah.
Well, it's convenient, and it's a great, like it's a bigger test than a unit test. That's a full page test. Like it's a kind of integration of it. Is everything still producing the same web page,
the same
output?
result?
Yeah.
And besides the server, go ahead, Sven.
Yeah, I just wanted to emphasize that it's nice to test both things, like the pure HTML and the visual representation of the HTML, because they can change independently, right? There could be invisible changes in the HTML that the web page snapshot can't see, and stuff might move around due to browser changes or something that isn't actually visible in the HTML, and have differences there.
Yeah, definitely.
And we should give Percy a shout out for their generous support of open source, because they provide a free Percy account for open source projects. So
we can leave a link as well.
It's great to see companies do that.
Yeah.
Right. And besides the server, there are many other tools and packages that you built. I saw there, for example, that there's a package to read the SPI.yml file, and so many other
so that's a file that package authors can put in their package repositories that when we gather the metadata and when we query each package repository, we pick up that file, and it's a way for package authors to give us preferences in terms of how, like who wrote the package, maybe if they want to override the author information, or if they want to provide some external documentation, or if they want to configure the build system in some way
differently.
We give them the ability to do that.
Yeah, but how the pieces connect? Because I saw that to add the package, I should go on GitHub and create an issue, and then that issue that probably becomes a PR somewhere, I assume,
Yep.
or it triggers some sort of flow, and then that's where that package goes in and fetches.
Yeah.
Or for example, another question I wondered is, you receive webhooks for each release once there's a release, once there's a tag, for example.
So the whole thing is kind of disconnected actually. So we have 3 processes internally that do all of the updating of the package metadata. We have one called reconciliation, which you're right that package adding process, all that does is it adds a Git repository URL into a JSON file in a separate repository under our organization on GitHub. And reconciliation constantly, every couple of minutes, checks the contents of that file, and if it sees any new packages or any packages that have been removed from that file, it will add package record into our database and start the whole process. So that kind of gets it into the database. We've then, the next process that again just constantly runs is called analysis, and what that one does is it checks out the source code for the package. It runs some Git commands to find out like how many versions you've got, and what the version dates were, and what the commit hash is.
No webhooks there.
No webhooks. We're just constantly polling. So we just, when we get to, it's the fourth bridge, isn't it? That they say that when they get to the end of painting it one way, they just turn around and start painting it the other way, because by the time they've finished, he's painting from the other end. So it's a bit like that with this. We're just constantly checking for package updates on all these repositories. We have 7,000 something packages at the moment, and so by the time we've finished, we definitely need to start checking again. So yeah, that checks out the package source code, runs Swift dump package on it, which turns the manifest into a JSON file that we can read, and then also does a whole load of Git commands to get history and things. And then the final step is called ingestion, and that checks online sources. So it goes to GitHub's API, and it says how many stars does it have, what's the license for this package, and a whole load of other data that GitHub kindly make available to us. And again, that process is just constantly running. So all 3 of those together make up the metadata side of the process. But then once we find new versions that we don't have build information for, or compatibility information for, or documentation building performed for, we then trigger builds and documentation builds based on the discovery of those new versions. So the whole thing is based on that one bit of information, the package URL going into our database, and from there everything else is kind of automatic, and everything is discovered from there.
Interesting. Sweet. All right, and to the next topic, which is important and very timely and sometimes even controversial in the community, Swift 6, strict concurrency. I see it as in the same way that Swift was very, very strict about the type system when it launched, and we were used to type you have ID equals something in Objective-C, right? We had we still have any in Swift, but in any case, it's not that used or not recommended, and we got used to it, right? But it was a change that was hard, and but now we have this move that is supposed to bring the same strong or strictness about typing to the topic of concurrency. In my opinion, this is a change that it's even harder than the move from Swift 2 to 3, because it's not only syntax, it's actually you need to think differently in the way that you program. And and you have this ready for Swift 6 report, right? Which you had 2 runs of it, or is it constantly running? So what are your thoughts on that? Like, and what made you have this idea and make it a report and have it as a source for the whole community?
Well, it was clear that, I mean, as you say, that's going to be a big change. And we sort of thought, and in discussions, it became clear that it would be really interesting to get a view, like an ecosystem-wide view. What is actually the state of affairs? What happens if projects are compiled with Swift 6 mode? And I think it's really important to tell that story also correctly, talking about the language modes, right? You have to actually actively enable Swift 6 mode in order to get that view and to get that strictness, be exposed to that strictness. And we wanted to give a sort of an early warning system or an early state of affairs. What happens if this starts running? And not just for package authors, this is also interesting for the Swift compiler team, because they are doing the beta process. And I think even now they are interested in tuning what gets reported, and there are some features there that actually suppress reports, because the compiler can be smarter about discovering when does something warrant a warning, or when is it perhaps even provable to the compiler without you annotating something as sendable or some such, and it still works, and take away that burden of you annotating your code, or as you say, of you thinking differently, because sometimes you don't need to think differently. Sometimes the compiler can do that inference for you and can see through your code and see that you're doing the safe thing, even though you're not explicit about it. So that was the idea. And we run this, and we've just earlier today, we started the 12th run with the release candidate of the Xcode 16 and the latest Swift 6 compiler. And yeah, we're just interested, like everyone, to see where we go with the number of warnings and the compatibility story overall.
Yeah, to be honest, I'm still behind. Like, I know the basics, async await, but when it gets to all the non-isolated, sendable,
I think it's important to emphasize that if you're doing anything towards this now, you're ahead of the game, not behind.
Exactly. Yeah.
Swift 6 is not. It's not even released out of beta yet. I mean, I know it's imminent. I would expect
probably by the time we publish this.
Potentially by the time we publish this.
Yeah.
But still, only at that point, it is the first time you can really be in this state of Swift 6, strict concurrency kind of readiness. But also, you don't need to opt in to Swift language mode until you're ready to. So you can use the Swift 6 compiler and Xcode 16 and all the modern tools without opting into the Swift 6 language mode. And so it's absolutely in your control as a software developer when you make that choice.
Just flip the switch.
Yeah.
And I'd even argue in many cases the wise choice is just not to do that like immediately, and give yourself time
to learn.
Do it on a branch, opt in, see what happens, and pick things that you can address. Some things are easy to fix. Sometimes you have maybe used a var when a let would have been all right. And there are lots of easy, just low-hanging fruit that you can pick off, and then you can move that into your normal code base. And over time, you can ensure that your Swift 6 language mode tracking branch has fewer and fewer issues if you want to do it that way, or just every once in a while let it run and see how many warnings do you get. I mean, effectively, that's what we're doing ecosystem-wide in our tests. We expose that number so you can see how your project is doing without you doing anything, but it's just going to your package page. But you can do that on your own and just see what warnings am I getting, which ones can I easily fix, and then also just give the compiler time, because API annotation and future Swift versions will probably also reduce your burden, because that's just the way it's moving. That's another piece that is also moving forward that you can just wait for.
Yeah, these are definitely great tips.
Yeah.
Go ahead.
Maybe one thing to stress is because I see this often where people complain this is throwing all these warnings at me. Why is it doing that? It is doing that because there are actually issues in how you're dealing with concurrency, and we can actually tell that story in our project. So we are Swift 6 language mode compatible now, and we had to fix warnings as well. And interestingly, we actually had rare crashes in production that were actually warned about. So we saw those warnings, and it turned out they're rare.
Very true.
But we actually, you looked at the code, you think, well, we're using a computed property. We were returning something, and, it was, you'd think, well, that's all right, but it was actually not a structure sendable that was returned. So actually multiple processes were modifying the return thing, and I held on to the same thing. And it was not obvious in the code, but the compiler said, look, this doesn't look right. And the crashes went away. So it is telling you something. Yes, there are also false positives where it says something, and there isn't anything there. But the vast majority of cases, it is actually highlighting things that you're probably lucky that they aren't biting you, but they will at some point potentially. So it's an improvement.
The other day I saw someone complaining that in a project which is only UI kit and app kit without zero concurrency, it was complaining about something. So yeah, as I said, there are definitely still false positives, but what I believe is that the people from the Swift compiler team, they're I'm sure they are around the clock, making sure that everything is working as it should be, even if we're not there.
Yeah, and I think it's just wise to treat this like any other API. Sort of, be cautious. It's a version 1 of that thing, and time will be on your side here. You don't feel pressured into moving too early, because it'll
jumping in.
Stuff will settle down. Don't. Like, how did Ben Cohen, I think in his talk, said, "Don't panic. Just chill and give it time."
Yeah. All right, and to finalize, I had one question which is more, not sure if personal, but more about feelings than code. So when you began the project of SPI, did you have in mind that one day it would get Apple to be an official sponsor, and in what other ways this is beneficial for the whole project and the whole community?
No, not initially. When we started the open source project, as when you start any project, you have really no idea what it's going to turn into. I think I certainly always knew that the idea was good, that we would need to have a package index. As a community, needed a package index, and I hoped it would become a significant and an important project, and I'm sure Sven felt the same that way, but we had absolutely no expectations that it would become what it has become. But one thing that was very clear to us is, as it did become something significant that we knew, a lot of open source projects, because a lot of open source projects are libraries rather than services. They don't come with quite the same level of maintenance, commitment that are running a website, especially a website that does all of the build infrastructure that we have behind it. It's a very significant website to run, and quite early on we did realize that it was not something we were going to just be able to put a few hours a week into and have it be like a side project. It needed to be sustainable for us. It needed to sustain the amount of effort and responsibility that it was to keep that site available. And so we had no expectation of Apple support or anything like that, but what we did realize quite quickly is that we need to find some way to keep it sustainable. And then the other thing to mention here is that the Apple support is much more than about just financial support. It is It is having an open line of communication with Apple and the Swift team.
It's having their blessing in some way, right? They're
absolutely yes,
yeah, absolutely, yeah. And that relationship that we've built with Apple over the last few years is incredibly important to us, and absolutely makes the product that we have on the website better for everybody. So they've been wonderful to work with. But also, we should also mention all of the other support that we get. So fantastic support on GitHub sponsors. So the community itself can sponsor and support the site through our GitHub page. And there's a link to that on the website, of course, which takes you through to GitHub sponsors. But also we have a couple of corporate sponsors at a time. So those are companies that are supporting the project, and they have a link on the homepage and a link in the supporters page as well. And then we also get help from infrastructure sponsors as well. So
Medium, right?
Mac Stadium is one of them. Our build system is running on in fact, we just wrote a blog post about our new build system. If you want to put that in the show notes.
I'll put also the link to the episodes where we talk about it, which is fascinating. Like I really enjoyed that episode.
And Microsoft as well. So Microsoft do all of our Linux hosting and our Linux build infrastructure. Nice. So we get lots of support
from everywhere.
Like it's not just that it's entirely supported and by Apple. So it's very much, it is a community site, and it's great to see Apple being part of community efforts like this. I think it's really admirable to see them do what they've done with the project.
Yeah. What about you, Sven? How did you feel when that became a reality?
That changed everything, because when I got in touch with Dave in 2020 about this, I was looking for a new project, and it soon became clear that this can't be a side project. As Dave said, we're nearing 3,500 issues on the server project, like closed and issues that we worked on, and pull requests. I think we're in more than 2,000 as well. It's just, there's a lot of work going through that project. Also in terms of developer support. So people have packages and they have issues. They open an issue, like my package says it's not compatible on macOS, but it builds. My documentation doesn't look right, and that sort of stuff we deal with. And then the hosting and all that. So it was clear that this needs more
full-time
work.
attention.
You can't do this in an evening. Yeah. But at the same time, Dave is running iOS Dev Weekly, and so he was in a better position there. But for me, it was really critical to get something more substantial than, as Dave said, we're super grateful. And early on, it was the only thing we had, like the GitHub sponsors and the corporate sponsors, but that was not enough to sustain two people's work on this. And it was just hugely helpful to get Apple, and that made the thing like we're on super solid footing now to just look forward and maybe, without any concern how we operate that thing.
Right. Yeah, makes sense. Congrats for this achievement. It's not.
Thank you.
I don't think. I don't think anyone would take that for granted. All right. I think we can wrap up here. In case people want to read more about SPI, I'm gonna leave links to the website, to the Ready for Swift 6 report. Maybe we're gonna have the third by the time we publish, to the podcast episode that I mentioned, and other relevant links. Besides that, where they can find you at?
So I don't do much social media these days, but I have a website, I guess, which hasn't been updated in a while, on daveverwer.com. But I guess that's the best place. Or actually, no, there is a better place. We have a Discord instance for the Swift Package Index project, and so that's linked from the README file in the repository. Actually, I think that's the only place it's linked. But yes, there's an open Discord instance that if you want to chat to us about the package, or if you're interested in contributing to the package, that's absolutely the best way to get hold of us. And but for me, I don't really do social media anymore.
Myself, it's finestructure.social. I've got a forward to my Mastodon account there, finestructure.social, and you can find me there.
All right, and all right, I'll leave a link there. Thank you both so much. I'm truly feel honored and happy and grateful that you joined.
It was our pleasure. Mm-hmm.
Thanks for having us.
All right.
Thank you.
Sure. And see you next time.
All right. Take care.
All right.